Take a look at the picture on the screen. Over here, you will find that the sun is shining brightly in the sky. Now, can you tell me what the color of the sunlight is? You're right. The sunlight, as you can see, is white in color. Now, take an example of another picture. Here you find certain light bulbs which are shining. Now, can you tell me what color of light is given out by these light bulbs? The answer again is white. Now, you must be having an obvious doubt in your mind that if the light bulbs are giving out white light and if sun is also giving out white light, when they are falling on the objects and after reflection, we should be able to see them only as white, right? But that is not the case. We are able to distinguish the colors in them. For example, if we look at leaves, they appear green to us. But why? If sunlight, that is white, falls on these leaves and is reflected back to our eyes, shouldn't they appear white in color? Also, if we consider oranges and apples, the color of an orange is, as you know, orange, and the color of the apple is red. But how are we able to see the colors if only white light is being reflected from them? Let us get to the bottom of this secret. Now look at the screen over here. Do you think white light is just one light? Such is not the case. White light actually hides something from us. That is, it is made up of 7 different colors. And the 7 different colors are violet, indigo, blue, green, yellow, orange, and red. Now you must be wondering that it might be difficult for you to remember these colors. Well, let me make it easier for you. You can remember these colors with the help of a very simple acronym. That acronym is V, I, B, G, Y, O, R. That is the first letters of the respective colors. It forms VIBGYOR. So with the help of VIBGYOR, you can remember the names of the colors. Now notice, if you recall from our previous discussion, violet has the lowest wavelength and red has the longest wavelength. Likewise, red has the lowest frequency and violet has the highest frequency. The wavelength increases in going from violet to red. Now let us take a look at a very interesting video. In this video, a multicolored disc has been taken containing several colors that we find in white light. Now this disc, when we see it normally, we can see all the colors present on it. Now what we do is, we mount this disc on a motor. Now when this motor is switched on, notice what happens. The disc will start rotating. Now observe that when the disc starts rotating, you are unable to distinguish the colors. The disc appears white when it starts rotating. So what does this tell us? This tells us that white light is indeed made up of 7 colors. And as we discussed, the 7 colors are violet, indigo, blue, green, yellow, orange, and red. That is VIBGYOR. This is an easy way to remember the 7 colors. Now let us get to the bottom of the mystery of the colors that we see around us. Now you know that an apple is an opaque object because when light falls on apple, it is not transmitted. Now let us see what happens. When sunlight is falling on apple, all the 7 colors are falling on it together. Now what apple does is, it absorbs all the colors, that is, it absorbs light of all 6 colors and it reflects red. That is, apart from red, all other colors are absorbed and red is reflected. So this reflected light reaches our eyes and thus we perceive an apple as red. Similar thing happens in case of oranges and leaves. A similar thing happens in case of oranges and leaves. So for an orange, when white light is incident on it, all light is absorbed except for orange. Orange is reflected. So when orange is reflected and reaches our eyes, we are able to perceive this orange as orange. And for leaves, what happens? Leaves absorb all light except for the color green. The color green is reflected by the leaves, and thus we perceive the leaves as green. Now notice the 7 colors that is present in white light again. These 7 colors are missing something, don't you think so? If you notice closely, you will find that there is no black in it. Now you know that there are several black objects that you find around you. Your hair is black. At night, there is darkness all around, which is also black. So what do you think is happening? What is black? Now look at this chair. This is a leather chair that is black in color. Now we just saw that black is absent from the spectrum. So how do you think you are able to perceive black? Let me tell you. Black is actually not a color. Black is the absence of colors. In other words, when white light is falling on this chair, no light is getting reflected. In other words, all the 7 colors are getting absorbed by this chair. And that is why this chair appears as black. Now tell me, do you know how our eye can distinguish between different colors? Let us find out. As we have talked about earlier, our eyes have certain special cells called rods and cones. Now, these cone cells are primarily of 3 types: a red cone cell, a green cone cell, and a blue cone cell. These red, green, and blue cone cells are responsible for creating the sensation of color in our eyes. And it is with the help of these cone cells that we are able to see and perceive color. Now you will obviously ask me that if there are only 3 kinds of cone cells, that is red, green, and blue. So if there are only 3 colors for the cone cells, how are we able to perceive millions of colors? Let us look at a video to find out how this happens. In this video, you will find that a white ball has been kept and it appears white. When blue light is shown on it, it appears blue. When blue and green shines on it, it appears cyan in color. And when blue, green, and red shine, it appears white in color again. Now notice what happens when one of the lights is shut off. When blue and red are shining, it appears magenta in color. When only red is shining, it appears red in color. Now when the red light is also shut off, you will notice that the white ball appears white again. So what did we learn? We learned that through a combination of red, green, and blue, we can observe and perceive various colors. Now let us find out how this happens through a simple simulation. In this simulation, I will demonstrate that in varying quantities, if red, green, and blue are mixed, we are able to perceive different colors. Now notice, I am activating the red torch. So you can see the person is seeing red. Now if I deactivate the red torch and activate the green torch, the person sees green. Likewise, if I switch off the green torch and switch on the blue torch, the person sees blue. Now what happens if I keep the blue torch and the red torch switched on? You will find that the person is seeing purple. Now I want to try out some different combination. I switch on the green torch and the red torch. We find that the person is seeing yellow. Now let us try out a random combination. Let us say we have a certain extent of green and a certain extent of blue. You will notice a lighter shade of blue is obtained. If I decrease the intensity of the blue torch, you will notice that the color shifts more towards green and sea green. So this tells us that if we mix the colors in different proportions, we are getting different colors. Also, if all three torches are active at the same time, you will find that the person perceives white. So what does this tell us? This tells us that when red, green and blue are mixed in different proportions, we are able to perceive different colors. So red, green and blue are the primary colors that enables us to perceive different colors when mixed in different proportions. Now we learnt about the presence of cone cells and how they are responsible for producing the sensation of color and light in us. Now why do you think we have rod cells along with them? What is the function of a rod cell? You will be interested to know that when you are in a dark room or in a very dimly lit room, you are unable to distinguish between colors, but you are still able to see to some extent. That is made possible by the rod cell. The function of the rod cells is to ensure that you are able to see in dim light or in darkness. But the rod cell fails at one point. That is, rod cells are not able to distinguish between colors. And it is due to this that you become colorblind when in the dark. It is the same reason why TV suppliers and manufacturers use only 3 colors to manufacture their TVs. That is, they only have red, green and blue bulbs. It is with the help of these bulbs and varying signals that monitor their strength, we are able to see and perceive millions of colors on the TV. For example, when you're watching your favorite program or your favorite game. So we learnt how we are able to see in the dark. Do you recall how we are able to see in the dark? We are able to see in the dark with the help, as I mentioned, of rod cells. These rod cells, unlike cone cells, cannot produce the sensation of light in us. That is, they are there only to help us see in darkness or dimly lit situations. The rod cells also fail when it comes to distinguishing between colors, because rod cells are unable to do so. That is why when you are in the dark, you become colorblind.